painting. So that's the easy one. So I think we're looking at this would be here. So you have 3 with VAV boxes, and this is it. There is fire dampers on every floor that obviously serve that airflow connection if there's a fire event. So to give you a speed, we're actually working on air handler air side. Air handler 3 serves the east side. It's a VAV air handler. Serves 9 VAV zones, 4 on the first floor, 4 on the second floor, and 1 VAV on the third level.
And which building is that? Is there 2, like a 3-story and a 4-story or something like that?
No, this is just, I would say it's on the lower roof, but it's just, you're right, one side is actually 3 levels, sorry, and the other one's 2 levels.
Oh, it's 3 and 2.
3 and 2.
So this one's, he said preliminary east side, first, second, and third floor, 9 VAVs.
On the 3 level, 2, 3, 3.
Yeah. So if you were to go, on the east side, it's just that air handler on the east side, you go on the roof, and there's all basically right below that space, so that air handler is basically where the VAV zones are. Probably certain classrooms only. Okay. So we can talk about air handler 2. Air handler 2, we'll go in reverse order. Air handler 2 is on what I would say is the south side, and then air handler 1 would be on the north. Okay. What's unique about air handler 2 is it serves some lab areas. However, it has return air. So there is a supply fan, there's a return fan, you have a economizer cycle, chilled water coil, hot water coil. However, it does not serve VAV boxes, it serves Phoenix valves. So you have some are high-speed valves, some are just the standard constant volume valves. But as you're well aware, it's a little more accurate as far as maintaining flows for lab conditions. And they work a little bit different than a VAV box. A VAV box looks at, if you guys remember, you have total pressure, which is the air that's looking at you when you're looking straight at the airstream. And then if you're taking pressure on the outside duct, then it's static pressure. So total pressure minus static pressure gives you velocity pressure, and then what you do is you have to do some math. You square root that value, it comes 4,005, gives you velocity, which that particular box at that point, the area of the duct, put that in the calculation, you have CFM. A Phoenix valve works basically on a bellows type. It's a Venturi valve, and it basically is set up on limitation within stroke. And there's a spring in there, and it maintains integrity based on differential. And if you put too much air against the Phoenix valve, the bellows goes back, it doesn't maintain its integrity, then it basically tries to close off. Once you get to the point where that spring can't overcome that pressure, then ultimately you fall out of its range. So it's more accurate, a little faster responding as far as the lab hoods themselves. They're really quick responding because they have to be based on continuing to provide the right foot per minute across the opening as you were to open and close the sash. So air handler 2 and again air handler 1, they serve, I guess, north and south. Again, they serve more or less labs in some of the classrooms. Again, air handler 2, it has a full economizer package. It has supply and return fans inside the cabinet. Same thing, high static switches, low static switches. Obviously, you have duct detectors and everything else associated to fire safety that's incorporated in all 3 air handlers.
So I'm sorry, those classrooms only, not labs?
They're labs. I guess they're lab classrooms. They're labs. Labs. Air handler 3 is more towards the classroom setting up this side.
So the labs have return air?
Some of the labs have, some of the classroom areas have return air. The labs, or I should say that east side or north south side, yeah, it has return air in the spaces. And also with that, it also serves all, airline 2 serves all the 2 levels. And then also serves the first floor center section, chill beams. So let me go a little more into air handler 1, and then we'll go on the drawing so you can see what I'm talking about. So again, air handler 2 is on the south side, and then air handler 1 is on the north side. 1 is 100% outside air. It's 100% outside air, feeding Phoenix valves in the labs. So if we have to provide 100% outside air in the labs, then we have to take the air out of the labs. So you have a separate exhaust system that actually removes that air out of the space, and so we don't make it positive, because then we don't want to make the labs positive, make it negative. There's the corridor. So we have 3 MK Plastics fans. They provided their own control panel to control those fans. It has its own static pressure reference. It's actually up in the unit. They have their own isolation dampers, so if one gets turned off, if one goes into alarm, the other one comes on, and they stage accordingly. It also has a bypass damper on the side of it. Ultimately, is to maintain stack velocity, and then there's another unique mode when we go into a fire mode that this particular damper opens, but just it has basically a damper to bypass air, so we can keep the stack velocity on those fans. Constantly maintain feet per minute, so we can again discharge the air above the building. The exhaust system for the labs doesn't just serve the north side, it also serves the south side. So, so that's something you guys need to make sure you take account of. It serves both sides. So you virtually have air handlers on the north and south side, but the exhaust is combined. Okay, so it's only one
What did you say
lab
the,
exhaust.
what did you say the theory on the staging on the exhaust fans is? How is it set up?
Yeah, I do not. The set point set for 1.50, and I know that there was concern that we make sure that we provide you images of all the set points that were implemented during the balancing, so that if there is a power failure or if you lose data, you'll be able to enter those values and get yourself back up and going. It's 1.5 is the set point that we have in the controller. What it does is it actually ramps, it opens up an isolation based on demand. So okay, we have a request to run. Obviously, a lab should be running 24/7, right? All these units can run 24/7. Air handler have to run 24/7, except air handler 3 can go off. But being the other air handler 1 and 2 are labs, it runs 24/7. So the set point is 1.50 based on the balance report and ultimately completion of the balance, and for the exhaust system. And what it does, it starts the first fan. It says if that fan runs to, you see the logic is 90%, for I think it's a matter of like a minute, then we stage on the second fan. So we stage on the second fan in rotation for equal runtime, and then once that set point's achieved, then obviously it backs off. One thing that's unique about this fan system, as far as the MK, often a tangent MK Plastics system, is that for their stack velocity, they actually look at the speed of the drive, and a lot of exhaust systems have a velocity sensor to maintain that. And in this particular product, they actually look at the fan curves, and they say, okay, if you have a fan, single one running at this speed, a little less than 38 hertz, then your velocity will match the requirements or be above the requirements that are needed to get the stack velocity high enough off the building. So that's been submitted, it's getting approved. But the driver's set for 38 minimum and 64 maximum as far as the range. So based on your question as far as demand request.
Yeah, entered it out stages.
Yep, so that runs at 80%, then what happens if in fact the fans start to reduce in speed, the value is, I think it's 15% to both fans to disable the fan. So it backs off and then it turns and disables the lag fan. So, one thing that's very nice about all your air handlers and your exhaust fans is they're all direct drive. So you have a motor that goes directly to the fan shaft. The air handlers are backward incline fans, and the exhaust, I think, is forward curve. So anyways, they're all direct coupled. In the air handlers, you have all the Baldwin motors, superheating Baldwin motors. The exhaust are different. I don't exactly remember which models they were, or makes. But anyways, so that makes it easier for maintaining. So basically you have filters. Obviously you have Zerk fittings on motors to provide, access to grease those motors. But in general, we have 3 air handlers, and we have an exhaust system. We do have one more fan that's not shown in the drawing, and that is we have an exhaust fan 4. The lab would be, 1, 2, 3. Exhaust fan 4 is serving the bathrooms, and the bathrooms are on the east side, and again, it serves all 3 levels. So that's
any minimum crossover capability? You lose number 3 for a week. Do we actually shut down those 9 locations?
that is correct.
And it's the same scenario, same question for the other 2.
Yes, there's no redundancy in the air handlers as far as having 2 fans in the cabin.
Besides open doors and tell folks that.
Yes. You do have the capability to function to put the fans in bypass. All the fans have drives with bypass sections. What I do personally on the ones that can do auto transfer, we do have 2 different drive manufacturers that are supporting your fans. On the air handlers, they're Danfoss drives. On the exhaust fans are ABBs. And also your chilled water, heating hot water pumps are also ABB drives. They're all in the network, they're all BACnet. They have their own unique address system so you can see it from the front end. So if you have a drive failure, you have the means of running things in hand. But in doing so, obviously the operator has to acknowledge that, I don't want to, I guess the safeties are still there, so she'll trip on a high limit, but if the VAV boxes are adjusting or if the Phoenix valves are adjusting, you may trip off on static reference.
That's fine, just a follow-up to just,
These are pretty typical issues we deal with on a daily basis.
do we have a speed controller we could swap out? Do we have a motor we could swap out? So that would be what it would, versus wait for something to be shipped. Let's just worthwhile, let's just check, what's our response when a speed controller, yes, there's several of them, but then, sometimes we end up swapping to be able to get priorities. We can shut down 9 rooms and then keep the other ones running or whatever, and do rescheduling, and most of these parts are available relatively right away, and if we have 10 locations or 15 on campus, it might be worthwhile to start thinking about the unique control, the universal controller that we could put in to get, not shut down the whole classroom. We could be up and running in an hour versus having to do that. The same thing with the motors. Yeah, are they all 2 horsepower? Are they all 5s?
Is there a volume damper on the outlet of these air handlers? If you're in bypass, you could clamp it down to reduce the static. Not ideal, but.
Yeah, there's no static damper,
Right.
other than a fire damper, which you don't want to change the position of it, but
Yeah, it's open or closed, yeah.
Okay, let's
Yeah.
just capture it as a follow-up, right, this discussion. Again, you're gonna look at the ease of changing out, the ease of maintaining, and changing out sometimes falls into changing out today, immediately, in the next hour type of thing. And if you don't have the means to do that, you can't get the stuff to the roof, you can't get, you can't get to those nuts and bolts that were all plastered up for people.
A lot of room for upstairs.
Upstairs, yeah, no, it's a very, I'm having some thoughts about thinking of a hot speed controller and a motor on the shelf. Again, if we've done a pretty good job of evening it out, because you could, you know, frame sizes are different, those kind of things, it's just,
A lot of change happens constantly in drives, we've dealt with that, like how to handle that as well, and part of the issue is that the drives are more and more advanced every year, so first of all, they're really reliable. Okay, we don't have very much breakdown on them, when we do, we usually have the capability to bypass around and work with the controls guy and make it work for the time being. In the meanwhile, since the drives change so much every year, when you call to get a part for an old drive, oftentimes you're just spinning your wheels and they wanna sell you a new style drive anyway. So, and they are unique, they're addressed different for the use, so it's a kind of a high price item to, just if it can leave on the shelf, much of them, you know, at least in our
Yeah,
experience so far.
that stuff goes out of warranty sitting on the shelf.
sure. So again, we just need to think about our mitigation, our countermeasures, to keep, you know, this $50 million piece of building running, at an occupancy level of over 99.9. So those are the kind of things that are slightly different, and I don't know how, you know, when we brought Aliso on, you know, we made a lot of changes, and you're right, Scotty. I mean, you gotta wait, you wait 30 days and they have a different rev number for a speed controller or any type of item. But let's just be ready, because they also, have universals, or like you say, the standard trick is do X, Y, Z, and then you're up and running, so, those are the tricks that we just have to make sure that we can easily do. So while we think through where to get the part, the new part, the old part, we're right now running on manual, it's easy to do. The class folks don't even sense anything's going on, and we don't have to change schedules. So it's gonna get tougher as the campus grows, and this is gonna be a pretty full building. Okay, thank you.
No, no problem. One benefit, not just here, but on your other BMTs that are on your campus, whether you Scala, DANFOS, ADB, you guys are familiar with, it's kind of offshoot as far as we're talking about snow, but, there's a logic in those drives. If you have a keypad, you can upload, once you basically set up the programming, you can upload those pre-programming changes in the keypad.
That's how
You
we
can
tend to
swap
do
it
it,
out.
we swap a drive, that's what we do.
You can swap it out.
Yeah, so before it's in the drives, if they do go out, it's beneficial to upload this information into your keypads. So then if it does go out, you can pull that keypad off, because currently it's not the keypad that always goes out, let's say it's the drive. But they can at least see the data that's already stored in it, you can take it over and copy and paste it. So,
Yeah, that saved us a couple times.
yeah, if you do it after the fact, obviously you can't restore that data because the drive is no longer functioning, so that's something that's definitely,
We order the drive and then off the serial number, the main parameters are set, you know, and then you just send it to the basic on-site stuff.
most definitely.
Yeah, HVAC applications aren't that complicated.
Right.
No, they're not.
Yeah.
They're making it more complicated. Like I said, I went to these Scala classes recently. And they're all very similar, but everybody has their own bells and whistles. It's more like auto tuning now is where the bigger
Right.
feature
Yeah.
is. That's where people are going.
Sure, that's the way they're all set up, and I bet they're all that way now.
Just gotta make sure auto tuning is something not like a turbine pump where it spins backward to shaft once a burn. Okay, so, I know this is a little hard to see. This is the first level. And to make matters, let's see if I can do this. This way. Maybe that'll help a little bit, only because this is how the building sits. So,
Upper right, that's the corner of the street with the steps coming in.
here, right there, this is the street. This is, I guess, when I would say, this is east side. So this is north, right, and south, west. So this is, area 3. Okay, so, 1, 2, 3, 4 spaces that even serves the bathrooms. last fan four, so it's just the bathrooms. So this is, you know, all three levels, the only thing on there, on level three, maybe it starts bathroom door. The lower part, which will be the north side, is air handler one. And then air handler two serves this entire area, plus the center section of the children units. Chill beams, have constant air valves. From the chill beam, they have a tube that comes off with the setting on the side, valve comes in, puts a pressure difference transmitter or meter on it, measures differential. He's looking for a certain value for a certain CFM based on what the slider bar is. So they all have been setting, it's like they're 8, and it looks like you're looking for 0.5, I can't remember exactly where it was, but they all should be the same as far as the CFM. And
It's per diffuser.
it's per chill beam, yeah, it's per chill beam, they're constant volume valves. And then,
This is the water side you're talking about?
this is the air side. Air side. Let me go ahead and, zoom in, sorry. Let's go here.
Just to understand, it's got a 100% outside makeup blower. And there's actual, there's valves that are maintaining a constant volume to each beam. Is that right?
Correct. That's correct. So let's just take a particular room on the south side. Air handler two. Here's your chill beam units. And the chill beam units are going into a, this one here is supplier valve. This one here is the constant air valve. It's upside down. This says CAV, that's what I was looking for. So we have constant airflow going to each one of the chill beam units. This is the returner.
You should see the application.
Yeah, returner off of air handler two. And then we have an SAV, supplier valve, that's modulating, that does some linears.
The left side similar to north hall, and then what, how do linears work? I'm sorry.
So linears is just a different type of diffuser, instead of being obviously a standard 24 by 24 register, it's just a long bar.
Distribute the.
The airflow. I remember this is where the professor sits, but in locations, but you have, these are changing, and SAV changes in basically on space temperature can vary, but the CAV is constant volume, so just constantly maintains. And we obviously, when we get the control side of it, which should be described, you know, how the air handler controls space temperature. We have to make sure we don't overcool the space, because we have cooling capabilities and we have heating capabilities in the unit. And so,
Is there an actuator on it, CAV, or is it just set in a particular?
it's set in a specific position. It's a bellows type, there's just a linkage arm, and then a spring bellows, there's no, like, you would consider an actuator. So they just move the slider bar, adjust it, loosen it up, adjust it, and then tighten it down, and then read the air distribution, providing the static pressure set point is established. What you normally do is a balance, you go like the worst case scenario room, which would be ultimately you think the furthest away, and you read pressure drop across the valve. And if you have a mean between the valve, based on the signal documentation, you know you have the proper amount of differential, so then you can set the airflow. Once you establish that point, you want to be like obviously mid-range of that scale, without being over aggressive and just wasting energy, just to push more air down the duct. We're looking to
Do
make
the fellows that if the static were to change, would compensate?
Yes, it does.
Maintain, okay.
Yes, it does. So again, on the south side, you have SAVs, you have a return fan. The return fan is a common duct that runs down the entire south side from east to west. And then, is an interior and a circulation. This is circulation. This is an FEV. This is basically serving a fume hood. So again, on the south side, you do have some interaction with the lab exhaust fans. So in those spaces, you have an SAV, they got CAVs, and you have a fume hood. Reason being is because once you increase or decrease the sash pipe position, you have to make up that air. So that's what the SAV does, because the constant air volume can't. So that would be kind of typical. The perimeter chill beams have heating in them, kind of off the hydraulic side, but the interior side, it's an interior side, I can't remember what these ones do. They just have to show water, while the exterior have heating. Heating and chill beams. For that perimeter heating. A little more elaborate. Again, it's the air handler. Two, and then if I were to get a room on the other side. Again, this whole center section, which we'll walk it, is off of air handler 2. And then we're looking at one of the zones on air handler 1. You have an SAV, or excuse me, the chill beams are supported by a constant air valve, which is here. What's different here is you have a general exhaust valve, and then you have a lab hood in the same space as a general exhaust. And then, I think that's it. Oh, then we have an SA supplier valve down here. What happens on the general exhaust / fume hood in a particular room, we try to control the room, obviously based on the chill beams. However, the hood itself has to maintain a specific feet per minute, whether it's closed or whether it's open. And also with that, we have different modes. We have a 0 mode, we have a 1 mode, we have a 2 mode, basically occupied, unoccupied. And we go from 4 air changes to 6 air changes. So I don't want to get into the whole elaborate part of how we're controlling the exhaust. We control.
Definitely, we're gonna cover that in the sequence of events.
Yes.
Sequence of operation, that really is kinda, we're gonna read it off of what the final one is. We know what the submission is, we kinda know some field changes that were done.
Yes.
But until we see the final marked up, cleaned up copy, then we would review it, starting with the controls folks. So that, it's really good that we have more than one type of operation in a classroom.
Yes.
Depending if it has the hood, the sash location, the SAV,
Supplier valves, yes.
and the location of the beams against the inner and outer. So those are all little things around the operating and control of the room. When any of those little things go bad is when these folks will get the call and then head in that direction. So again, they normally kind of know where to go, but it's going to be a couple slightly different items that are not in another building today. So those are the things to put eyeballs on. I like to get 25% sink in today or more, and then folks will come back and tell me that it doesn't make sense. We want to review this, and reading it in the sequence of events when you get a trouble call will really help. So those are still things that are missing as part of the final training. After we do the controls, is come back and say, when we're done, this is how things are going.
Right, so just in general control, if you have a fume hood and your sash is open and you have to have 100 feet per minute across that sash, then the general exhaust valve backs off. And if you're at 4, let's say you're at 4 air changes, no matter if you're at 4 or 6 air changes, you gotta remember the relationship between the general exhaust valve and the fume hood exhaust will oppose each other. So when close the sash, the flare flow through the fume hood reduces, although it still has to have its requirements as far as being a negative to the space. However, at that point, the general exhaust picks up.
Is it all proportional, or does it different, does it follow different algorithm for the change?
Yeah, it should be fully proportional between the two of them.
Oh,
Yeah.
sure.
So that comes from one or the
Yeah,
other.
it's simple, so.
Yep, one or the other. So as you close it, the general exhaust goes up. As you open it, the general exhaust goes down, and the rest of the air goes through the fume hood.
Because you got it down.
Yep. So you always have to maintain the condition, not say from the, well, you have to have condition from the fume hood to the space, but not so much the space to the corridor, right? Those rooms become negative. They're going to be negative to the corridor, and the fume hood's negative to the space.
Yeah, keep it on jelly though. Waste of time.
And again, the north side, air handler one, is 100% outside air all the time. Okay. Fortunately, there's, I would say very few fire dampers, but you're lucky there's not a lot of them. Commonly just coming out of the shafts. Is where the majority of the fire dampers are. So, that being said,
I've had a lot of issues lately with fire dampers.
These are these motorized or they're thermal?
they're a combination of smoke dampers, will be both. So, for air handler 3, this is the yeah, I can.
Yeah, just gotta go to the bottom.
Yeah.
Not as easy as you like.
I know, I mean,
That'll be all right.
keep going up to the.
I'm close, I can't see it,
So, you have the same thing on level 2, which is go to the floor, but I would say the 9, but this is more. I'll show you where we're at. And then air hammer 2, this is the return air hammer 2, and this is supply. And then air hammer 1, it has a supply in here. And then the exhaust, there's no fire dampers. Exhaust is not fire dampers. So air 1, 2, and 3, 1 being, you know, go back and review it. 1 was north side labs, 100% outside air. 2 is south side labs and classrooms with returner, 2 fans, supply and return. Air 3, VAD, 9 zones. The next topic would be split systems. We have 2 different types of split systems that are here on this project at West Sierra Hall. One of the package units would be just your standard York split system, it's 5 tons. It actually serves the elevator machine room, which is up in the highest growth. Standard thermostat, cooling only, very basic. Evaporators just outside of the elevator machine room. There's fire dampers that are associated to that room because you need to have 3-hour rating. What I personally did is I wired the end switches that are the auxiliary end switches for the fire dampers into the control circuit that powers up the unit. Because common what happens, dampers closed, it's commanded on, ice is up, you know, water leaking everywhere, so I just incorporated that, those safeties or switches in with the control. So it's pretty easy, pretty basic. Real quick, the other units, let me find my drawings here in my drawing here. you know, obviously the units, they're all energy ladder handlers. Then we go down to our Baldwin motors. We have a complete package of. This is actually on the Bluebeam Studio, which I thought you guys might have today. Installation manuals, you know, what about the motors, greasing them. This is all part of the package that's on Bluebeam. Motor wiring. So here you go.
Try to get this to, facilities and link, and then from your surfaces, you can pull these up at any time. Trying to avoid putting anything on the G drive. So you have it all in one location. And then as the leads or supervisors put together work orders to go investigate stuff, they could either tag the facility link file or just you folks have access to it now today. So that's kind of the plan, how it works in our system today, Craig.
Probably more like 20 minutes and then
I just wanted to go over a camera battery, so I charge that. I'm using my phone right now, but. yeah.
Okay. So in this thing, there's lots and lots of literature. There's orders, 700 some odd pages. Talks about the drives. So we go into split systems. Again, this is the 30 unit serves the elevator machine room. This is standard work unit.
We have one split system, right?
No, that's,
There's Douglas splits for.
Yeah,
This is a ducted split system. for-
We're trying to eliminate some of those, Scotty was the question, that's why I didn't figure out what the last count was.
True.
You know, just bleed off the main system so we don't have to have these two splits.
six. You have six.
Six on the drawing, I just.
Yeah, you have six,
For the typical Douglas split, like the last new building, the multi-city stuff, right?
that's correct.
Nothing to it. And then one yard, the standard split system, 5 nine.
Well, I think it's that, you wanna give me the. Yeah, see how that makes you the Plumey, Mitsubishi condensing units for outdoor units. They do specifically heating and cooling, they don't do heating and cooling simultaneously, like a VRF, style.
Right.
They
Learn that.
don't have the valve boxes,
These are heat pump though, they will.
they will heat. So,
They are all heat pumps.
they're heat pumps. They have heating and cooling capabilities. I did not personally go to the evaporators and flip the dip switches on so they don't provide heating, because that's how you set that up. Because you can disable it based on the design criteria with heating and cooling. They use their, you know, little data rooms, IDF closets, and those kinds of things. They also, they made electrical room.
How many condensing units do we have?
We have, 6 of them,
Condensing units.
6 condensing units, and,
For 6 coils?
no.
Can't be.
So, the main electrical room and the main IDF closet in the first floor, we'll walk them so you can identify what goes where. The condensing unit, if it's, you know, condensing unit number 6, you're gonna have fan coil 6-1 or fan coil 6-2. So, it does get a bit confusing knowing where they go, but level 1, get me wrong, there's 2 evaporators on 1 condenser that serve the main electrical room and the main IDF closet on the first level. Then you have an adjacent electrical room. Again, it's probably best for me to walk them and show you where they're all at.
It's included in the.
Yeah,
So again, the main question is to know how many branch off. So there's no confusion when you take one down, where it's really all going.
Yeah, we have to go back on the as-built drawing.
That's fine.
Um,
Again, like Scotty said, they're real familiar with them, but just know how many spreads they have, that's all.
correct. What it is we have, two, Mitsubishi, Mr. Slims, and there's 4 of the Pumi style. The Mr. Slims, again, I'll point out what goes where, are on the south side electrical rooms. They're dedicated to the room. The only thing about different between Mr. Slim and the Pumi is, that, at least that, the VRV, is using the MNet. MNet that communicates to the evaporator, that communicates to the stats, where the Mr. Slim unit is basically a power line carrier control in which the power goes to the condensing unit, high voltage power, and then out of the condensing unit, it powers up the evaporator, right? Even though they have their own isolation switch or disconnect switches, so that you can secure them all, you have to remember that the power comes from the condensing unit on the style unit. Whereas the other ones, it's basically, they have their individual power sources and they give you different voltages. It's just that you have the Mitsubishi, called the MNet communication wiring, which is just 2 wires that go to each device. So it's on a network. All of the evaporators on the Mitsubishi units have condensate pumps. The condensate pumps have, a high flow or high level switch that we disable the unit if it gets too high.
Yeah, they installed this, I went and looked, they installed a little external. That's fine, that's good.
And he has the overflow on the condensate dam area.
Cause they're on a wall, so the fan is the floor, I mean,
Yeah,
that's
So
all.
if it gets too high, it shuts off. So
It shuts off.
So it's off, so then it should just.
Right.
Alright, so thank you.
initially I got involved with site construction and with Berg, and we walked the locations because I knew this issue was going to come up. What happens when they freeze? What happens when they have excessive condensate? We repositioned the units as fast as we could to get them away from the electrical gear. So that was, there was
Keep
only.
raising electrical, you're higher anyway, so.
Yeah, there's only there's one location, and I get from Maine, I get from on the first level, we actually are putting a diversion piece so that if it does, it goes away from the Phoenix server that controls the lab goods. We've sent an RFI for that for approval, and we were accepted that, otherwise, they want the pans and everything. There's really no means of putting a pan or those Mitsubishi will be able to get up to access it, plus the air blows up in front of it, so you put a pan in front of it, it's gonna, the air's gonna hit the floor.
Plus it's down enough, broke to the pan overflows then. Maybe.
So, are you guys familiar with the MNet, MNet adapter? There's another one here for you, for this project. Basically, you can use your laptop.
Yeah, we never got the adapter with the other building, we've just talked about this, that's not the way we talked to
Well, on Madera Hall, they've got the controller with the connection there. You can connect. We didn't need the adapter, but it has a problem with Windows 7, it's not reliable, it's not a stable platform or something. I was able to get data for a while, but it didn't work.
So, this is tendency number 4. I personally, went through and measured up all the piping as you would for refrigerant charges. But I actually put in, on this plate of thermostat, it's gonna send you, I can remember what it is. It tells you the address. These are as-built, this is part of our as-built package. I don't know how many guys have been in class, you probably should go to a Mitsubishi class if you've done, they're quite elaborate. The only thing that's very, very, I would say unusual, but very unique, is that you're not supposed to be able to charge them by adding refrigerant. The concept of these units is that You do it based on the footage and the calculations using the Mitsubishi Diamond design. So as you put this together, it tells you how much additional grid you have to put in the system. So,
Andy, did you charge the last building? Is it the last Mitsubishi you did up
That
there?
was a construction company.
yeah, so this is the only way that they tell you that you can charge it if it's 410A. Pull the charge out, you have a leak, re-evacuate it and put it in based on the model. So these models are very important to you guys as far as how much charge has got to go in. So you have, you know, the refrigerant comes charge that came from the condensing unit and the additional refrigerant that's needed to charge it properly.
It's not? Right on, yeah.
So again, this is the configuration. We have one system. I think it has 3. If I remember right. Let's see, 6. Let's see, 7. And let's see, 7. The CU8 has 3 evaporators. Again, we mark them for the room 13, 12, 22, 12, 22, and 3. Again, it talks about how much additional refrigerant is required and the length of run and calculation. So these definitely have to be provided to you. They're actually part of already in the blue beam.
Is it all 410?
410, yes.
All 410?
They're all 410, yeah. This is your standard Mitsubishi Mr. Sun. Just what you see all back there is in the
That's
comments.
a unit 8. You said there was 6.
Well,
We have 8.
it goes to 1, 2, 3, 4, 5, 6. 6 split Mitsubishi units, 2 being Mr. Slim, and then 4 being the
Right.
Kumis, and then like you mentioned, this is 8 where it has 3 evaporators.
How did it get labeled connecting in 8 if there's only 6? I don't know. So there's missing numbers that.
We don't have one for the elevator room, right?
The one for the elevator room,
And there's another one.
which is 5.
Which is,
Which
So
is
they
5.
just lumped all the condensing units, it didn't matter what style or kind or anything.
I think what they did was make it irrationally, I don't think irrationally, they're in 1, 2, and 3. Cummins unit 4, 5, 6, 7, 8. Anyways, that's the process they took that. So these are the Mitsubishi split systems again. I personally can't sit here and describe to you in detail, you know, all the service codes and all those things.
we looked into the class, I think we're attempting.
Yeah.
Right.
We're working on our training budget and, getting better at it, so.
I've been to the class and I've been to actually 2 other courses, so I can start to hear it, but they're pretty elaborate and it gets really, really advanced.
The amount of data is just endless on those things.
Mm, Especially the ones that have, the valve boxes, where you get heating and cooling simultaneously at the same time.
Yeah.
It's just
Branch
really,
controller, yeah.
exactly.
So but we don't have branch controllers, it's
No.
just hard pipe.
No, that's correct. So we want to take a break, take a moment.